Today I want to talk about one-sided limits of a function and their relation to the limit of that function. Let's start our discussion about one-sided limits of a function with an example. Consider the function f of x equals x squared when x is less than 1 and f of x is equal to 3 minus x when x is greater than 1. And also here we have a graph of this function. Now suppose that we want to answer to this question. What is the limit of this function f when x approaches 1? If you remember from our previous video, we emphasized that when x approaches to any point, x can be on either side of that point, left side or right side. And if you notice to the graph of this function or the rule of this function, you can see that when x is less than 1, the rule of the function is x squared. When x is greater than 1, the rule of this function is 3 minus x. So we have different rules around point 1. And because x can be on either side of 1, so we should consider two separate cases to find the limit of the function. One case is when x is less than 1, and one case is when x is greater than 1. Notice again that when x approaches 1, x is very, very close to 1, x is not equal to 1, x is only very, very close to 1, but x can be on either side, left side or right side. So we compute left limit and right limit separately, and then we find the limit of the function at 1. We show the left limit of a function by this notation and the right limit of a function by this notation. First, note that how I read these two notations. Limit of f of x as x approaches to 1 from the left. Limit of f of x as x approaches 1 from the right. This notation means that values of x are very, very close to 1, but their values are less than 1. And this notation means that values of x are very, very close to 1, but their values are greater than 1. Now let's compute left limit of the function. We can find left limit of the function from its equation and also from its graph. First, we find left limit of the function from its equation. Because in left limit, values of x are less than 1, we must use x squared to compute left limit. So the left limit of our function is equal to limit of x squared when x approaches to 1 from the left. To compute this limit, we plug in 1 in x squared. If we plug in 1 in x squared, 1 squared is 1. So the left limit of our function is equal to 1. Now let's find the left limit of the function from its graph. If we get closer and closer to 1 from the left, but on the graph of the function, you can see that the corresponding y values of the function approach to 1. They get closer and closer to 1. If we get very, very close to 1 from the left, the corresponding y values of the function will get closer and closer to 1. So from the graph of the function and also from its equation, we can find left limit of the function. Now let's find the right limit of our function as x approaches 1 from the right. As x approaches 1 from the right, the values of x are very, very close to 1, but their values are greater than 1. So from our piecewise function, between x squared and 3 minus x, we choose the second piece, because when x is greater than 1, the function is equal to 3 minus x. So the right limit, to find the right limit, we choose the second piece, and the right limit is equal to limit of 3 minus x as x approaches 1. And to find this limit, we can substitute 1 for x, and we get 3 minus 1. 3 minus 1 is equal to 2. Also, we can find the right limit of the function from its graph. As we approach to 1 from the right, but on the graph, the corresponding y values of the function get closer and closer to 2. Now that we have the right limit and left limit of our function, let's back to our question. What is the limit of f of x as x approaches 1? We know that as x approaches 1, x can be on either side of 1. X can be on the left side and x can be on the right side. And because of that, sometimes we call the limit of a function the two-sided limit of the function. And the two-sided limit, or simply the limit of the function, exists if both of the one-sided limit exist and equal to the same thing. Otherwise, we say the limit of the function or two-sided limit of the function does not exist. In our question, the left limit of our function is equal to 1. The right limit of the function is equal to 2. And because these values are not equal, so the limit of the function does not exist. In general, we have the following relation between the two-sided limit of a function and the one-sided limits of that function. Limit of a function like f as x approaches a is equal to L if and only if the left limit and right limit of that function exist and equal to the same value. Otherwise, if the left limit or right limit does not exist or they do not equal to the same value, the limit of the function does not exist. Let's try another example. Again, we have a piecewise function. Our function is equal to 3 minus x when x is less than 2. When x is greater than 2, our function is equal to a square root of x minus 1. And when x is equal to 2, our function is equal to 2. Also, here you can see a graph of this function. The question is, what is the limit of this function as x approaches to 2 from the left? We know that when x approaches to 2 from the left, the values of x are less than 2. And our function is equal to 3 minus x when x is less than 2. So the left limit of our function is equal to limit of 3 minus x as x approaches to 2 from the left. And to find this limit, we just need a simple plug-in. If we substitute 2 for x, we have 3 minus 2, which is equal to 1. So the left limit of our function is equal to 1. The next question is, what is the limit of this function as x approaches to 2 from the right? When x approaches to 2 from the right, the values of x are greater than 2. And because our function is equal to a square root of x minus 1 when x is greater than 2, so the right limit of our function is equal to limit of a square root of x minus 1 as x approaches to 2. And if we substitute 2 for x, we have a square root of 2 minus 1. 2 minus 1 is 1. A square root of 1 is equal to 1. So the left limit is equal to 1. The right limit is also equal to 1. And we can conclude that the limit of our function as x approaches to 2 is also equal to 1. Also, from the graph of the function, we can see that if we get closer and closer to 2 from either side, the corresponding y values of the function get closer and closer to 1. For example, if we get very close to 2 from the left, the corresponding y value of the function also get closer and closer to 1. The next question is, what is the value of our function at 2? From the equation of our function, when x is equal to 2, the y value of the function is also 2. So f of 2 is equal to 2. Also, we can find f of 2 from the graph of our function. When x equals 2, the corresponding y value of our function equals 2. Let's try another problem. Suppose f of x equals 2x plus 1 when x is greater than 1. When x is less than 1, f of x equals 3 minus x. And when x equals 1, f of x equals 15. The first question is, what is the limit of this function as x approaches to 1 from the right? We know that when x approaches to 1 from the right, the values of x are greater than 1. So, from the equation of our function, we choose the first piece, because when x is greater than 1, f of x is equal to 2x plus 1. So the right limit will become limit of 2x plus 1 as x approaches to 1. And if we substitute 1 for x, we have 2 times 1, 2, plus 1, 3. So the right limit of this function at 1 equals 3. The next question is, what is the limit of this function as x approaches to 1 from the left? When x approaches to 1 from the left, the values of x are less than 1. So to find the left limit of this function, we choose 3 minus x. And the left limit is equal to limit of 3 minus x as x approaches to 1. And if we plug in 1 for x, we have 3 minus 1, which is equal to 2. And the next question is, what is the limit of the function as x approaches to 1? This limit is a two-sided limit, and we know that the limit of a function at a point exists if and only if the right limit and left limit both exist and they will be equal. But the right limit and left limit are not equal, so the limit of the function at 1 does not exist. And the last question is, what is the value of this function at 1? From the equation of this function, when x equals 1, f of x equals 15. So the value of this function at 1 is 15. Now let's see problems related to one-sided limits similar to AP Calculus exams. The graph of a function is given, and we are asked to find the limit of this function as x approaches to -5 from the right. If we get closer and closer to -5 from the right, but on the graph of the function, we can see that the corresponding y values of the function get closer and closer to 7. So the right limit at -5 is equal to 7. And also we are asked to find the left limit at -5. If we get closer and closer to -5 from the left, also we can see that the corresponding y values approach to 7. So the left limit is also 7. And because the left limit and right limit both exist and they are equal, so the limit of the function at -5 is also equal to 7. And also we want to find the value of the function at -5. When x is exactly -5, the corresponding y value of the function equals 3. So f of -5 is 3. In the same graph, we are asked to find the limit of the function as x approaches to -2 from the right. If we approach to -2 from the right on the graph, you can see that the corresponding y value of the function approach to 2. If we get closer and closer to -2 from the right, the graph of the function, the corresponding y values of the function approach to 2. So the right limit of the function at -2 equals 2. And also we want to find the left limit at -2. If we approach to -2 from the left, the graph of the function, if we look at the graph of the function, the corresponding y values of the function approach 2. So the left limit is also equals 2. And because left limit and right limit both exist and they are equal, the limit of the function at -2 exists and equals 2 as well. And at last we want to find the value of the function at -2. And of course the value of the function at -2 equals 2. When x is exactly -2, the y value of the function exactly is 2. So the limit of the function is 2, and also the value of the function at -2 is 2. Again, in the same graph, we are asked to find the limit of the function as x approaches to 1 from the right. If we approach from the right to 1, but on the graph, if we get closer and closer to 1 from the right, the corresponding y values of the function approach to 4. If we get closer and closer to 1 from the right, the corresponding y values of the function get closer and closer to 4. So the right limit at 1 is 4. And also we want to find the left limit at 1. If we get closer and closer to 1 from the left, but on the graph of the function, if we get very close to 1 from the left, the corresponding y values of the function get closer and closer to -3. If you notice, when we are very close to 1 from the left, the corresponding y values of the function get very close to -3. So left limit at 1 equals -3. And because left limit and right limit of the function at 1 are not equal, so the limit of the function at 1 does not exist. And also we want to find the value of the function at 1. When x is exactly 1, the y value of the function equals 6. Let's see the next question. What is the limit of this function as x approaches to 4? We know that as x approaches to 4, x can be on either side of 4. X can be on the left side of 4, and also x can be on the right side of 4. To find the answer of this limit, we need to find left limit and right limit, and then we can answer to this question. Let's first find the limit of this function as x approaches to 4 from the left. If we get closer and closer to 4 from the left, but on the graph, if we get very close to 4 from the left, the corresponding y value of the function gets closer and closer to -2. And also, if we get closer and closer to 4 from the right, the corresponding y values of the function approach to -2 as well. So the left limit and the right limit of the function both exist, and they are equal to -2. And so we can conclude that the limit of the function as x approaches to 4 exists and is equal to -2. And also we want to find the value of the function at 4. When x is exactly 4, there is no y value corresponding to 4. Notice that here we have a hole. There's no y corresponding to 4. So the function is not defined at 4. And the answer of this question is that the function at 4 is undefined. See you in the next video.